Today I will discuss the Mason-Gaine formula. The Mason-Gaine formula is used for the determination of overall transfer function. It is an easy way of finding the relation between the input and output variable from single flow graph. On other hand, we can say that any complex block diagram can be converted into signal flow graph, and the transfer function can be easily obtained using Mason-Gaine formula. The Mason-Gaine formula is T is equal to 1 by del summation of p suffix k into del suffix k, where the k is equal to number of forward path. P suffix k is equal to path gain of the k forward path. Del is equal to determinant of the graph. Determinant of the graph. The 1 minus within bracket sum of the individual loop gain. Sum of the individual loop gain. Suppose it is a signal flow graph. Here from 1 to 7 it is a forward path. It's called the forward path. Number 1, 2, 3, 4, 5, 6, 7 are the node. The load, the sum of the individual loop gain. I had connected the node between 5 to 6. It's called the loop. Another loop, it is the feedback path minus h1, and this the another loop is h2. So that is forward path. It is a loop. Here it is loop. It is a loop. The sum of the gain product of all combination of two non-touching loop. The sum of the gain product of all combination of 3. So it is a Mason-Gaine formula to find out the transfer function of signal flow graph. We take an example for clear confusion. Suppose the signal flow graph. We can take example the find the C by R of the following signal flow graph using Mason-Gaine formula. So it is a signal flow graph. We will find out the transfer function by using Mason-Gaine formula. So here at first we find out the forward path. Here the number of forward path are 2. The forward path 1 forward path 1 is 1 to 7. Five, 6, 7. The G1, G2, the G4, and the G5. It is a forward path from 1 to 7. G1 is the transfer function, G1, G2, G4, G5. Therefore, path gain is equal to path gain whose p is equal to the product of transfer function the g1 g2 g4 g5 g1 g2 g4 and g5. Second forward part to forward path to is 4 5 6 and 7 1 2 3 4 5 6 7. Here the transfer function g1 between the 3 and 4 is g2 and between 4 to 5. Here the transfer function is g3. The path gain p2 is equal to g1 g2 g3. Here the two forward path, the path gain is here, another path gain is here, two path gain. The first step, second step, we will find out the loop gain. Here the number of loops is number of single loops are 6. So loop 1, 2 3 4 5 6 7 3 4 5 6 7. Loop 4 to 5 and 5 to 6. The feedback path is connected with the transfer function g4 g5 negative feedback element h2. The loop 1 we get from the signal flow graph. Let's see in the loop 4 it is a one loop. Here will be the another loop, it is a one loop, it is another loop. Therefore loop gain L1 is equal to minus g4 g5 g4 into g5 into 2. Then loop 2 1 2 3 4 5 6 7 3 4 5 6 7. 3 to 4, 4 to 5 and 5 to 6. They connected to node 3 feedback element is minus h1. the the loop on the second, therefore the loop gain is equal to loop gain L2 is equal to minus G2 G4 G5 H on. This is the product of G2 G4 G5 and minus H on. Loop 3. Here the loop the 3 is from 2 to 6 G1 G2 G3 and negative feedback. The loop gain is equal to minus G1 G2 G3. Similarly, the G and loop 4 is equal to G2 G3 G4 G5 G6 with a negative feedback. Total the loop we will find the 6. Then the loop 5 2 3 4 5 6 7 4 5 6 7. The 3 to 4 is connected and 4 to 6 and 6 to 3. 3 to 4 is G2, 4 to 6 is G3. It is negative H1 feedback. So loop 5, the loop gain L5 is equal to minus G2 G3 H1. And last loop 6 2 3 4 5 6 7 1 3 4 5 6 7. Now 4 to 6 4 to 6 and 6 to H naught. And the transfer function where the G3 where the feedback is H2. For loop gain L6 is equal to minus G3 H2 G3 H2. The Mason gain formula T is equal to 1 by del summation of P suffix k into del suffix k, where the del is equal to determinant of the graph is equal to 1 minus sum of the individual loop gain. Here we find the get number of loop. When the number of loop will get is 6. All the loop gain is summation. We know that the del is equal to 1 minus within bracket sum of all individual loop gain. Sum of all individual loop gain. Individual loop gain. Sum of the all individual loop gain. Here the loop gain we got a 6. Therefore del is equal to 1 minus here the loop n minus h2 g4 g5 minus g2 g4 g5 h1 minus g1 g2 g2 g4 g5 minus g1 g2 g3 minus g2 g3 h1 minus g3 h2 bracket close, then plus 0. 0 means the sum of gain product or possible combination of two non-touching loops. Here this graph the no non-touching loops, therefore here will be 0. Then del is equal to 1 plus h2 g4 to g. Here the minus is common for all loop gain. Then after calculation 1 plus g2 g4 and g5 and one number of forward path 1 minus 0 is equal to 1, del 2 is 1 minus 0 is equal to 1. Since all the loops are touching to the forward path, all the loops are touching the two forward path, therefore the Mason's gear formula ts is equal to 1 by del into p1 into del 1 plus p2 into del 2. Then the transfer function t within bracket s is equal to it is the transfer function t is equal to g1 g2 g4 g5 plus g1 g2 g4 toward the forward path. Here the put the value of forward path, first forward path it is and second forward path is, and the lower part is the sum of all individual loop gain. The lower path, this value is equal to this value. This value I will put here. Now this is the signal flow. This is the transfer function of signal flow graph.